Hello everyone. In this video, going to share about typecasting in Java. My pronunciation is not that great. Please forgive me for any mispronunciations. The views shared are only personal opinion. Does not intend to hurt anyone's sentiment. Recommend discretion. Typecasting in Java is the process of converting the value of one data type into another data type. The conversion can be done either automatically or manually. The automatic conversion is performed by the Java compiler and a programmer performs manual conversion when necessary. General syntax. Types of typecasting. There are two types of typecasting: widening typecasting and narrowing typecasting. Widening typecasting is converting a lower data type into higher data type, also known as implicit conversion or casting down, which is done automatically by the compiler itself. It is safe because there is no chance of data loss. Here is the order of widening typecasting. Example. Here two things to consider. On implicit conversion, both data types must be compatible with each other and the target type must be larger than the source type. So if you try to convert int data type to char or boolean, that cannot be done automatically as integer data type is not compatible with char or boolean. Narrowing typecasting is converting a higher data type into a lower data type, also known as explicit conversion or casting up, must be performed manually by the programmer. If you do not perform casting on higher data type to lower data type conversion, then the compiler will throw an error. The narrowing typecasting order. Example. Types of explicit casting. Apart from the primitive data types explicit conversions, there is also explicit casting with respect to inherited classes in Java. Mainly, there are two types of explicit casting: explicit upcasting and explicit downcasting. Explicit casting is casting a subclass type to a superclass type in the inheritance tree's upward direction. That is, when a subclass object is referenced by a superclass reference variable. This is an automatic process which is triggered without any further code change. Downcasting occurs when a subclass type refers to an object of the superclass type. This must be performed manually by the programmer, else the compiler will throw runtime class cast exception. Only option is to use the instance of operator. In a sense, downcast of an object is possible only if it has already been cast. Why do we need typecasting in Java? Prevent data loss. On conversions, we need to ensure that we don't lose any valuable information, and typecasting helps us to convert data safely with its integrity intact. Improves memory efficiency. Without typecasting, larger data type might be used for a smaller value, which can bring a wastage of memory. Thus, typecasting helps in managing memory usage efficiently. Better control. Java is strict about data types, unlike some other programming languages that are lenient. Typecasting allows programmers to take complete control and ensure the correct data type is used at the right time. Let's look at some examples to understand in detail. I have a class demo typecasting. Inside the main method, declared a variable int a equal to 5. First part is an example for widening typecasting. So let's convert the integer variable into higher order data type long b equal to a. The compiler automatically converts the integer data type value to long data type value. Implicit casting occurs, and here the value of b long variable will be 5. The next line is conversion of long to float, another level of higher order conversion. Again, no problem, and the value of c float variable will also be 5. To show that implicit conversion happened as expected, printing integer, long, and float variables. For narrowing typecasting, that is higher order to lower order, declared variable double d equal to 10.12. The narrow typecasting needs to be performed manually. That is explicit typecasting converting double to long here. If we don't specify the long type explicitly, we will get compile time error. In this conversion, we will lose data after decimal point of the double variable. The fractional part will be lost and the value of the long variable e will be the last conversion of long to int. Here again, f value will be 10. Remember, the value ranges that we discussed on data types episode of this series. It plays a role here. If the long value exceeds the range of the int, once again, there will be data loss. Finally, printing the values before and after conversion to showcase narrowing typecasting. Let's execute and verify the output. The output is printed as expected. For the explicit casting types with inheritance, have a parent class with a method and a child class that extends the parent, one more method on child class as well. The methods on these classes are to show the capability of making calls after the casting. Now to the class demo explicit casting. Inside the main method, for the sample parent class variable, created an object with sample child class. This is explicit casting conversion of subclass to superclass type. Though the object is created from child class, only parent class method will be accessible. I had mentioned earlier, downcast of an object is possible only if it has been already upcast. For the sample child class variable, assigning sample parent class object that was upcast earlier with explicit typecasted to sample child. The object of child class can access superclass method and its own method as well. Let's execute and verify the output. The output is printed as expected. Casting is one of the powerful and important features in Java that provides ability to convert variable of one type to another. Understanding typecasting is essential to write quality code. To write error-free Java programs, proper knowledge on typecasting is needed. Make sure to understand and to practice programs with typecasting.